Hello everyone. October 29th. Let's get started. Sort integers by the number of 1 bits. You're given an integer array. Sort the integers in the array in ascending order by the number of 1s in their binary representation. And in case of 2 or more integers have the same number of 1s, you have to sort them in ascending order. Return the array after sorting. So let's see if we can solve this without. I doubt it. I think you have to get a comparator. I never really do a comparator in Java, have I? It's always comparator compare int, but it's not necessarily just an int, right? I say arrays dot sort array comparator dot comparing function compare compare int. No, it's not compare int. Yeah, I can't. Java comparator compare. Without comparing, I just want to see a comparator. Compare to. Key extractor. A negative value. Okay. Compares by that sort key. How do you do like 2 level of compare? Comparator multiple conditions. All right, so a comparator now I'm not using Java streams. Oh, you do compare to. I see. Oh, what is this? Then comparing. I mean, it's not extractor, right? It's not extractor. Comparing is to extract. I don't think this one is extract. I think maybe the best way is just to write a new comparator. Okay, how would you write? So a new comparator. Oh, that's not. It's, oh, hold a second. It's not an object. Huh. Now I have to convert back and forth 2 times. But compare int is not going to work. mean, compare int is, yeah. I actually have no idea. I think we'll have to, if you want to use this, you have to turn this into a list. So, right, array list equals new array list. Arrays dot. Oh, I think I can directly do this, right? Arrays dot as list. Can I do that? Nope. How to convert array to array list? I never memorize. I never remember this. Oh, inside. New array list. You put this one inside. Tell me it's not right. Because the array, I think it's because it's a different. Yeah, it never worked for me. I think it's because it's integer and this is not integer. Provided required type list integer. Provided, I don't understand. Yeah, I think it's because this is the problem. It has to be element. Or it has to be element. Here now is not right. Okay, so just loop it. Oh, maybe list off. I saw a list off. Oh no, list off has to. Nah, that's not gonna work. Yeah, it's not gonna work. Screw it. So we'll do new array list for int a of array. It's okay. Array list dot add a. Okay. Now we can say array list dot sort new comparator. Oh wow! Look at that. Holy guacamole. That's the one. That is the stuff. Right? Okay, so what we need to do is to compare 01 and 02. Right? So we say count bit 01 equal to integer dot bit count 01, right? Count bit 02 integer dot bit count 02, and if int comp bit equal to comparator, no, count bit dot wait, hold on. How did you do the compare to? Like, this doesn't have compare to, right? Integer has compare to, but this one doesn't. Can I do, you know, integer? Integer, probably can't. It's a primitive. You know what? We know. All right, we just say if count bit 1 is larger than count bit this, will return a positive value, return 1. Else if count bit 1 is smaller than, I will return -1. Else, right? So they're the same. Once they're the same, then we need to return. See, that is the thing, because this returns an int. I shall return. Can I say integer? Oh, O1, O2 are integers. So can I say O1 dot compared to O2? Oh, that's actually not that bad, right? So we do that. Wait, why this one's anonymous can be replaced with lambda? How replace with lambda? Oh, without sort you can put the lambda. Now this I can agree with. This is very easy to do. And I sorted. Can I return array list? I can't. Dot to array. I can't. Ugh. You're kidding me. Oh my goodness. For and I equal to 0 as smaller than array list dot size I plus plus, or the fillet res I equal to array list dot get I. Then we return res. I'm curious, like what's the, say, correct answer for this? Yeah, I think this one will be right, but it just looks bad. But I don't know. I don't know how we can do this without converting to yeah, it's definitely not the right solution, I think. Well, I do not know the syntax to sort primitive array with you know what? Why don't you just give it a shot? I mean, we have this already, right? Can I just say, you know, can I just do this? Arrays dot sort array. Required type provided is T. Yeah, I don't think. Can I say dot to it's, how do I get to int? Can I cast it to int? Maybe I cast it to int. I cast it to integer. Well, it'll be new integer, so no. I mean, it's 10 to the 4, so I probably can just return O1 minus O2. Is it not right? Oh, wait, but doesn't have compared to? It does not. Ugh. Yeah, it's not gonna work. So yeah, I don't know how to solve this without. Yeah, my knowledge in Java, in Java is lacking. Thus, I have no idea how to solve this problem without converting array to an array list of integer first. Call it O and log n, but we all know it's just have to check the solution to see like how do you do this in Java. I really no idea. And the verbosity is ridiculous, right? All right, compare. How do you do this? Oh my lord. It's pretty complex as well. So yeah, it's turning this. Look at this. So you arrays, you string this. I have not learned what boxed means. And then two array. And two array, each one will get, what the hell is this? Get a new. Oh, this is convert this. I'd rather write this. I think performance-wise, it should be similar. Oh, wait, hold a second. That's different. This is integer array. This is array list. But you have to return back to array anyway. Oh, this is array list. I see. We can... so I don't have to turn this into array list. I can turn it into but I think overall it's the same, right? It's the same. I mean, just so I don't do that. All I need is integer, right? I do integer. And then we say array.length. And then I don't like to do this. I mean, how can I memorize this, right? And I think who said that? John Skeet, right? He said, you will have to loop no matter what. So might as well just loop it yourself. So just, save some effort. I really don't like how you have to just remember all. Now this is not array list, right? So we just call it, how do I call it? Array int. It's a stupid name, but what the hell, man? It will work. Array I. Right? So we do that, and then we call arrays.sort. Array int. Yeah, think it will work. Yeah, I like to do it this way. I mean, it's the same. And then at the end, we still have to, I still have to do this again because, or maybe there's a way. Okay, let's see, convert integer array to int array. Is there a faster way to do this? Nope. This is what I want. Ugh. Nope. This is a one line, ridiculously long one. Hold on, maybe it is faster. Who knows? Yeah, I don't know. Maybe it is faster, but I don't care. There's a one line minus two lines. It's okay. We just need to make small changes here, and then we are array int. All right, so this one, hold a second. Yeah, it will work. Use integer array instead of array list. Probably can be faster. I think it'll be faster. Nope. Nope. Yeah, that's alright. Don't care. I think the most important part of this is to learn that you can do this lambda expression. I like lambda expression. It's similar to Python, right? The Python thing about 2 lines. Yeah. Yeah, that's you have to like the simplicity of doing this. Bit manipulation. What? Jesus. All right, just read through, see what this one does. Hamming weight. And what's a Hamming weight? A single set bit initial. Wait, how do you not sort using the built-in methods? If you have to use the built-in method, you have to sort. You have to use a comparator. What the hell? What's the built-in method you're talking about? Count a bit? I don't need the built-in method to count a bit. I can turn it into a binary values and I can count the bit myself. So this is one of those just ridiculous interview questions if they ask something like this. Or anyway, what's a Hamming weight? Increased Hamming weight by 1 and then continue to the next position by left shifting the mask, which moves the single bit. Oh, oh my goodness. I know what this one is. So I think the built-in method is you cannot do binary. Right? You're not provided with a way to convert this into a binary number. So yeah, if you haven't provided, you're not allowed to use it, then yes, you just do 31 times. Exactly. And you it is as stupid as it can get. Yeah, you'll have to find weight. Basically, just this is not weight, right? It's just number of bits. I guess that it's called a Hamming weight. All right, it's pretty stupid. All right, how about Brian's? It's one of the pioneers in C. I haven't read his book, the history of C, right, or Unix, the history of Unix. So it's basically the number of set bits, right? For a given num, we run the algorithm until num equal to 0. That is, the algorithm runs until there are no more set bits. At each iteration, we remove the least significant bit. Once all the bits are removed, the num equal to 0 and the algorithm terminates. The number of iterations is the number of set bits, since we remove 1 bit per iteration. So how do we remove the least significant bit? All we need to do is AND with num minus 1. Num minus 1. least significant bit. Every bit to the right will be 0. That means when we subtract 1, least significant bit becomes 0, and every bit to the right becomes 1. And now every bit to the right is, after we end the operation, every bit to the right of the remains 0, and when you AND those two, or you exclusive of those two, everything to the left is completely unchanged when subtracting by 1. Thus, performing this will not change any of these bits. And the only net change is that the least significant bit was set to 0. So our numbers are we increment weight. We do this, set num to this, and do it again until it becomes 0. So that's how you count. Oh, so your count will be faster. Yeah, you count with, so instead of counting 31 times every single time, this has to go, well, not necessarily 31, but this is a set number of, not necessarily, depending on the size of number, right? The size of num. But this is you will move the number of, just the number of bits. You essentially do the number of bits. So num and num minus 1 and n minus 1, which guarantees the only thing change is the least significant bit. That's pretty smart, but I'll never use this. It's not better. It's not a question of which one's better. It's just a question. You might be asked this in an interview, right, for a company, and if you do, I mean, in the current job market, you just probably have to suck it up. But I mean, it's pretty smart, right? It is pretty smart. If you do say embedded programming or not, there's no library, and you need to count the number of set bits. That could be a way. All right, let's go back to this one more time. I actually still remember how this one is solved. Parallel courses. It's just saying you have a bunch of courses, and then there's a relation. You have to take 1 first before taking 3. You have to take 2 before taking 3. And it's asking, and also each class has its minimum time to finish. So the question is, what's the question? The minimum number of money to complete all the courses. So this is going to be solved by if I remember correctly, it's a DFS, right? And we can start from any, because the initial idea I have for this is topological sort, right? Topological sort. But I think it didn't work. And there is an official solution with topological sort, but I forget about that. I do remember is a DFS. And it does not require topological sort because you can start from any you can start from anyone, right? You start from anyone and you just go to some position, and when you go to the position, you set the maximum, the earliest time that this one can go, right? The earliest time that this one can go, and you set it to a value. So in this case, if you start from 1 and you set the 3 to 3, so the earliest month that it can go is after 3 months, right? And then you start from 2, right? And you start from 2, you go here. The earliest here is 3. It's larger, so we keep the largest one. So it's still the earliest to go is 3. And from 3 to go is going to be 8. So the earliest to go from here is 8, and then the answer is 8. And in this case, right, we can actually draw it, right? We can draw this. So you have 1, 2, 3, 4, 5, right? Doesn't matter, we just start from 1. Okay, start from 1, and then at 5 is 1 month, right? And so for 2, at 5 will be 2 months. Start from 3, because it's a BFS, so we'll go to 5. So it'll be 3 months. But another path to go to 4, 4 will be 3 months, right? And then we go 4. 4 is 3 months already. So 4 go here, requires 7 months. So this one turns to 7. And then we go 5. 5 goes, so this one will eventually go to 12 months. It's a brilliant idea, right? So basically what we're gonna do is just implement this thing again. So the way I'm gonna do is we're gonna say months, the starting month, earliest starts. Okay, that's this. And then we say earliest starts equals a new int n. Okay. Then we need private void DFS. We need a class. Okay, I'll call it node. I can call it class. That's it. And we do need relations, right? Relations. Oh, relations. It's gonna be a graph. So we're gonna do a graph. How would you do this graph? I'll do it as a it could be int of int, but the inner int you don't know how long. So I want the inner to be an array list. So it's going to be a array list. It's gonna be wait, hold on. Is this one? Can we do this? Yeah. Ha. That is the graph. Okay. So graph will equal to list, my goodness, integer n. Yeah, it doesn't work. It doesn't work. All right. How do I do this? An array of array list. Oh, cannot create arrays of parameters. Okay, you can't. You cannot. So it's fine. So list of integer. It's okay. That is completely fine. New array list of, that's fine, right? Then what? Then, ugh. Because you have to go through everything, and then, yeah, how you gonna do that? You might have to use a map, right? You might have to use a map. Yeah, I think a map is more realistic. So it's not array lists, it's a hash map, right? So we use a hash map. Hash map of integer and this, right? So we use a hash map. And then for int a tuple of relations, right? And we say if graph.contains key top 0, right? If it does not contain key, yeah, we also going to just do -1. If it contains key, then graph.get top 0 -1 dot add top 1 -1, right? Else, if it does not contain key, dot put top 0 -1, a new array list yeah, let's do this. If it does not contain, then we'll put yeah, that's the right way to do it. And then, right, and then we do this. So that we set up the graph, and then we have the graph, we have the earliest starts, then we can do the DFS. So for each one, what we're going to do is, we also need the result. Perfect. So we are in class, right? Yeah. So what do? We say for int child of graph dot get or default class should be array list empty. How'd you get an empty array list? Empty list. Collections dot list is a certain syntax. That's just, hold on, it's gonna be a collection, right? Collection dot empty list. Oh, I guess that's fine. So for child of, so it's child, then we shall say, we have to put one more, the time. Int time. Okay. Then this dot time equal to time. So we'll say, right, for each child, earliest starts child equal to math.maximum earliest starts child, earliest starts class. Oh, it's just do parent. That's fine. Just do let's just do a class plus time class. So we've done all of that, right? And then do we move on? Yeah, we move on. So we'll DFS, handle the current, and then but aren't you repeating? Yeah, you just do it once. You do it once. Yes, we do it once. And then we say res equal to mass.max res and earliest. Not necessarily. Not necessarily. No. Right, so we handle all of that, and once we are done. Wait, hold a second. What if the class 1 is the last class to take? That is fine. That is fine. I think we just need to go through. Yeah, you know what? This is not right. This is not right. So what we're gonna do is just do that. But then where's the DFS part? If you're just gonna go through every class, right? You go through the first class. Do we keep going? Yeah, the first class we go, and the second class we go, and each one I go to one class. So yeah, I do think we have to keep going. But if we keep going, some paths might be repeated. Right? Some paths might be repeated. Then what? Yeah, some path might be repeated. Or do you have to do... Oh, maybe we need to do a DFS. Yeah, if it's a BFS, if it's a DFS, I pick whichever, right, and I go. Then I have to pick another one, then I go. Another one, I go. And then what? You run all the edges. But how do you know you've run all the edges? Right? You have to start from each one. You know what? I don't think that's the way. I think we should still find out the I think we should still find out the starting points. But I remember the DFS method don't need to find a starting point. So what we need to do is prevent repeatedly going through a stuff, right? And then we find repeatedly going through a stuff. So how do we do that? How do we avoid repeatedly go through a stuff? Well, how do I know that I mean, I could, right? I could just DFS. Then I think it will be solved, but it might be too slow. Or the other way is you DFS only go one level down, right? But if you go one level down, then you have the problem. If you go one level down, yeah, you have a problem. You cannot just go one level down. Hey, what is the DFS method? I remember there is a DFS method. Is this a DFS method? Yes, this is the DFS method. I think so. DFS and the DP. DPI, oh, I didn't use DP, but I used early start, so it's the same thing. The minimum time needed to finish all the classes starting from node I. DPI is the minimum time needed to finish all the classes starting from node. Okay, so DPI is the minimum time needed to finish all the classes. Minimum time is starting from here, okay? Then I'll DFS this regardless from where we are. So I'm starting from any point, and I say I want to find DPI, and I don't know. So I go to its children, okay? So I go to its children, and the children would tell me the minimum time they need, and I will need to find a maximum among all my children. Okay? So if I starting from any point, it doesn't matter because I go down, right? I go down and starting from a certain point, I just want to know what is the minimum time I need. So I go look all my children. If I don't have any children, the time is going to be me. Be myself, right? The amount of time I need to take. If I have children, then I'll ask them and I pick the maximum among them. Well, that's different, right? It's different. Like from this, I feel like I can't really do it. It's kind of, yeah, it's very different, right? No, it's not. Let's call it min time needed. Yes, that's stupid. Let's call it DP. We know what this is. This is DP, right? This is DP. So I should say DPI is the min time needed to complete class I. Then we can do that, and we say if DPI is larger than 0, DP class, right, is larger than 0, that means I've done this already. So we just return DP class, right? Otherwise, I haven't done it. So, oh yeah, this one can be int. Otherwise, what you're gonna do is DP class will equal to time class. So we have to take this, right? And we'll have to take this much time. And then we'll go through all my children, right? We'll go through all my children to find, you know what? I don't need to do that. I just say DP class or equal to math.maximum dp class and dfs child. Okay, so all my children, what is the DFS of them? We find a maximum of them. Once I done dp class plus equal to time I take for me to done. Once I finish all that, I'll return dp class. So that's DFS. And what we do is we'll go through everybody because we need to treat everyone to be the starting point. And I get a res. Okay, I say for int I equal to 0 I smaller than n I plus plus. We do DFS I. We do res equal to maximum math.maximum res and DFS I, and we'll return res. All right, is this correct? Don't know. Feels right. Let's see. I think this is right. Ooh, it's like almost two times as slow. What the hell? I don't think it's only been a week, like 2 weeks. I don't think they're increasing the test cases. I don't think test cases is the same. All right, what was this implementation? I implement use list of list. I see. I see. I think I did better here, right? Yeah, it's much simpler, this one, compared to this. And dp and time int this, yeah, so it's faster because, okay, let's try use list. Oh yeah, then they'll always have key. Okay, all right. Array list. All right, but you have to go through. Yeah, I have to say for int I equal to 0, small to n. Right, I plus plus. And we say graph.add new array list, initializing. Then we just do this. Oh, dummy. That's true, I can do it here. Nice. Oh, this is better. Right? And then we do that. You get this dot add this. And in fact, let's put this in one. Oh, we just dot get. Okay, let's make sure this one's correct as well. Yep, that's faster. So yeah, because hash map, there's a hashing process, and hashing takes time. Now we have to do this one more time. And I read the solution. Not good enough. I have to refer to the previous solution for hints. on how the DFS shall work. Right? I'll have to do it again. Another thing to note is that using list of lists to represent graph can be faster than a hash map because there is no need to hash anything. Or check whether key is in the hash map. All right, that's fine. But what was the original solution? I think this is the one I put myself. Oof. So this is a topological sort. Yes. Latest time needed to reach any node. Yeah, so that's my idea. That's not my idea. That's what I was trying with, right? To find the latest time needed to reach each level. And this determines the earliest time that the node next node can start. So we keep track of the earliest time that the node can start executing. Yes, but this requires a topological sort. Well, I was trying the DFS, and these two are different methods, right? These two are different methods. But we have to do integers, right? We have to do integers and stuff. Do a queue, ticks, we'll pull it, and with the add will be ticks child plus time node. Takes node plus So we set up the latest time. Once we're done, yeah, that's how I was thinking. Right? This is the method I was thinking. So I still have the residual memory of that, but it is not DFS. This is topological sort. So what do we do with this? We have to put it down. We need to do this one again. Unfortunately. Next one is to flat this list. What is this one? Longest palindrome. Oh. We'll do the Manaches. Oh, Manaches. This is some DP, right? I might skip to this one. I mean, they've been staying here for a while. This problem. I've been thinking about this actually some nights. The number of good integers, right? Number of good integers. Yeah. Anyway, that'll be it for today. I'll see you guys tomorrow. Adios.